is where we're going to start talking. Having that bit of information, I need to kind of give you a little bit more insight. So if you're taking notes, this is where you would start as far as things that I need to kind of memorize. And we don't do that very often in this class, but what I'm talking about with this next couple ones that I'm going to work with is not on your bright colored sheet of paper, but you will be able to utilize them to become part of your bright colored sheet of paper. Okay? So the first thing we did last week is we talked about the 6 trigonometric identities. I alluded to them the other day. We talked about them a little bit. Okay? And we talked about them in terms of x and y, what they were equivalent to. So as a review for a moment, sine is equivalent to what? Y. Right? So if I'm looking at my unit circle and I'm looking at the ordered pair, I'm looking at the y value. Looking at the next one, cosine is equivalent to x. The tan is equivalent to y over x. So do me a favor. Look at the bright colored sheet of paper where I told you to begin. What does it say about tangent? It equals sine over cosine. The other day we discussed that. When I gave you the y and the x and I put y over x, it makes sense that the sine over cosine is the tangent. So they're actually giving you that on that bright colored sheet of paper. Okay? Now, over here, what did I tell you about the cosecant? It's the reciprocal of sine. What did I tell you about secant? Again, reciprocal of cosine. And cotan, the reciprocal. Okay, those are considered the reciprocal identities. Oh, look at that. Nice. My secret Santa knows what I like. It's my favorite candy in the world. Yeah, I'm excited. Okay. Okay, you got that on film?
Yes.
I'm not eating it because I'm diabetic, just in case you want to know. All right. Just in case somebody asks. Okay, so what we're going to talk about here is that these are what we call reciprocals of each other. We recognize that, hopefully, with the x and the 1 over x, the y, the 1 over y, etc., vice versa. Y over 1 over y, x, 1 over x, right? Because they're reciprocal identities, you actually can rewrite them as reciprocals of each other. So, for example, the word sine is equal to 1 over cosecant. The word cosecant is going to be equal to 1 over sine. Okay? Because they're reciprocals of each other.
Mm-hmm.
Does that make sense so far? So, for example, if I told you 1 was 2, the other one would be 1/2. Right? If I told you 1 was 3, the other would be 1/3. So now we're looking at this and we see that they're reciprocals of each other. How are we going to write these as reciprocals of each other? Okay, this is going to be 1 over secant. Okay, and this is going to be 1 over cosine. Are we okay so far? What did we say about the word tan? The word tan is equal to sine over cosine. That's a given. So 2 different ways that we can work with tan. Tan can be considered sine over cosine. So therefore cotan could be considered cosine over sine. So far?
Mm-hmm.
Okay. The other way around. Tangent is also the reciprocal of cotan. So this could be considered 1 over cotan, where this could be considered 1 over tan. Are we good?
Mm-hmm.
These are what we refer to as the reciprocal identities. Okay? Reciprocal identities are not something that's given to you on your bright colored sheet of paper, but you need to be able to recognize them. So far, okay? All right, I'm going to put up an actual worksheet that has them written out for you.
And this isn't on the bright colored sheet of paper?
No, this is actually kind of compacted onto one where I feel like it, if you want me to turn off the light, it might be a little better for you, but I feel it says it a little easier, okay? So if you look, the reciprocal and also known as the quotient identities, okay? You have sine as 1 over cosecant, where cosecant is 1 over sine, exactly what I wrote up there for you. Cosine is 1 over secant, secant is 1 over cosine. And then tan can be written in 2 different ways as I wrote up there. Are we good so far? Again, not on your bright colored sheet of paper, something that you need to know, just right off the top of your head, you need to be able to figure that one out. Are we good so far? Now, look down on your bright colored sheet of paper for the next identity. What is the next identity? Okay, yeah, it has squares going on. They are called the Pythagorean Identities. If I was to say by far the most important identities that you're going to utilize, these would be the ones, okay? So these are the ones that you need to be able to recognize right off the bat. So if I'm writing notes on these, I see the originals. I see the sine squared plus cosine squared equals 1. I see tangent squared plus 1 equals secant squared. And I see cotan squared plus 1 equals cosecant squared. What I challenge my students every year to do is rewrite them, individually rewrite them in multiple ways. Okay, so for example, I'll do the word sine squared plus cosine squared equals 1 with you, so then you get a feel for what I'm talking about. So anytime I see the word sine squared on my paper, I need to think, okay, Pythagorean identity might work here. So that might be where I want to kind of work with. So when I'm looking to rewrite them, a lot of times people recognize sine squared plus cosine squared really with no problem. They get kind of excited. I know you don't see that yet, but you're going to go like, oh, that's cool, it's 1, because I see it. But what they don't see is variations of that. So what I'm saying here is I want to see how many different ways can I write these 3 items and where they all mean the same thing. So the first example I would say is let's solve for sine squared. Mm-hmm. So what do I do when I solve for sine squared? I subtract cosine squared. So on a paper, if the answer that comes up is 1 minus cosine squared, I would go, oh, wow, that's cool, that's sine squared. Does that make sense? Mm-hmm. Okay, what's another alternative way that I could write this? So cosine squared
equals 1 minus sine squared.
Okay, very good. Another alternative way that I should recognize that these are still considered Pythagorean identities. Not given to you on your bright colored sheet of paper, but you know that if you solve for one in terms of the other, you can do that. I think it's natural that you can do this, but not natural to recognize it. Okay? So on a piece of paper, if the answer cosine squared comes up, you can go, oh, I can rewrite that as 1 minus sine squared. Now I need you to think outside the box with me for a minute, and think of you guys as a teacher for a minute, and think of a mistake that somebody could make if they see, one of these things. What could they do? Yeah.
They don't have a square.
See, they don't have a square. They think they could, because they're all like squareds going on. Sine is squared, cosine squared, and 1 is really squared, 1 squared. They just decide, oh, I can square root everything, right? Can you? Can you do that? Like, what is this? Cosine squared equals 1 minus sine squared. Can I just square root, and have fun? No, I cannot. Because what does square root of each thing mean? Well, if I wanted to get back to the original, it meant that thing times itself. So what would 1 minus sine squared, if I just think in my mind that I square root, remember this is a no-no. If I got 1 minus sine, if I squared that, I would get 1 minus 2 sine plus sine squared, which is not what I would started with. So keep in mind, you cannot just square root these and think you got the answer. Are we good with what I just said? Mm-hmm. So one of the no-nos is thinking that because everything is squared, you can square root each piece individually. You can't do that. This is a quantity in itself that would have to be square rooted. Okay, now, having said that, you see how I want you to rewrite the Pythagorean identities? I'd like you to take the next 2 Pythagorean identities and do the same thing with it. Rewrite it in the multiple ways. Okay? So on your notes, this would be a place that you would rewrite them in multiple ways. All right? I'm going to do equals secant squared minus tan squared. Yeah, you see that? And did you also get tan squared equals secant squared minus 1?
Yeah.
Okay, so everybody kind of sees what I'm talking about. Now, the hard part is to be able to recognize it. So what my brain always thinks when I'm doing these problems is if I see something that's squared, I should automatically think Pythagorean identities and see if I can kind of make that work for me. Okay? Over here, cotan squared plus 1 equals cosecant squared. Okay, so if I'm looking at that, I could subtract the cotan squared, and it's 1 minus that. Or vice versa, I could solve for cotan squared, and it's cosecant squared minus 1. Everybody good? So those are the three components of each of the identities that, although these are the main guys, the other ones are really important because those are the ones you want to be able to recognize. So far, okay? Also, on your bright colored sheet of paper are the sum and difference formulas and the double angles. We'll come back to that. We'll utilize them for sure. But I want to start with the basics for today. What's that? Yeah, oh, good. No, we're going to utilize them for sure. The half angle, we won't use in AICE mathematics. But the other two we will 100% use. Okay? So those are important as well. But again, they're given to you on your bright colored sheet of paper, so it's not that as difficult to work with. Alrighty, so. Now, the next thing we're going to do, I just kind of borrowed this from somebody else's website, because typically these types of problems, again, I started with telling you there's multiple ways that this can work. There are two main ones that we're going to work with this week. One is considered what we call simplify, okay? And what simplify does is it gives you some blanket things to work with, and you kind of clean it up until you can't clean it up anymore. So for example, in something that we're familiar with, 2/4. I say, okay, so my answer is 2/4, and you tell me, Ms. K, your answer is truly 1/2. You know that because you reduced it to lowest terms. Well, how do you know 1/2 is done? Well, it's because it's prime. They're both prime. There's nothing else that can go into them. And that's kind of the mentality that you're going to use for simplifying. You're going to clean it up till you can't clean it up any longer. Okay? And then there's one that's going to be called verify. It looks just like simplify, but it has equals and an answer. So literally, it gives you the answer. You're going to have to take one side, clean it up, and make it look like the other side. Okay, so those are the two we're going to work with this week.
So that's like when they gave us the volume formula and we had to make the...
Somewhat. It's like you're taking one and make it look like the other. Absolutely. It's kind of like that. But this is, to me, it's like a big puzzle. It's a lot of fun. You know, anyway, I think it's fun. Okay, so what we're going to do is we're going to start with, for example, number 3. Okay? So I'd like you to write down number 3. And we're going to talk through, remember my old lady skills that I have. We're going to talk through how I make this work probably the easiest way. So you got secant, and notice, okay, another thing to notice while I'm thinking out loud, they have a t here, a t here, a t here. Earlier we had thetas. Sometimes we have x's. It doesn't matter. These are what we call the angle of them. So, you know, typically when we work with trig identities, we're talking angles. Okay, and so whatever these variables are, it's not, don't let them mess you up. They're just letters. Yes?
Is that multiplication?
No, they're just actually secant of t, tan of t. You could have secant theta, tan theta, cosine theta. You could have, you know.
So it's like commas.
Yeah. And then a lot of times people just write secant, tan, cosine, and in the end stick the t in instead of having to put the t every time they're working it. And I'm okay with that. I'm okay with that. So, secant of t, okay,
1 over cos.
tan of t, and cosine of t. Now, when doing these problems, my old lady tricks that will help you every time. So when doing these problems, the first thing that I think to myself is I want to take whatever trig identities we have up there, I want to try to convert them to sines and cosines first. Okay, so that's typically where I begin to look. I see, are there any squareds? No. So now I'm going to try to work them in terms of sines and cosines. So for example, what is secant equivalent to if I was rewriting it with the word sines and cosines?
1 over cosine.
So it is 1 over cosine. So I'm going to take this guy and I'm going to rewrite it as 1 over cosine of t. Everybody good? What's the next guy in terms of sines and cosines? So in this case, it's sine over cosine. And last but not least, cosine is already cosine, so I'm going to leave it. Okay? Now, truly, if I think of it this way, these are 3 fractions multiplied by each other, right? Fraction, fraction, really over 1, fraction. So what do I do when I have fractions? I can clean them up, right? I can start reducing, cleaning them up. So what do I see that I can start to reduce or clean?
A cosine and a cosine.
So cosine goes away with a cosine. Good.
And then you just have tan.
And then what do I have? And 1s don't really matter, right? The 1 and 1, we don't care. It's not that we don't care about 1, but we don't care about 1 right now. And so what happens? I have sine over cosine,
Which is
So
tan.
and clean it up to its lowest form. In this case, it's tangent of t. Done. Okay? So, yes.
With the variables there, if the what you call if like the t is gonna confuse you, could you put like the theta in there
Yeah.
instead?
Yeah.
And then
I would ask that you try to, on an AICE test, I think that your probably best bet is to make sure you go back to the original one at the end. Because you're going to solve for that variable typically in part II. Okay? Makes sense? Okay, so that was, I think, what I would consider a real simplistic one to start with. So let's go and see if we can kind of muster through a few of them and kind of work through that. So for example, tan squared plus 1 over 1 plus cotan squared. When I see squared, I should originally just say, okay, I think of Pythagorean identities, right? Before I try to go into terms of sines and cosines, I think, do the Pythagorean identities look like any of these? Okay? So you're looking at your Pythagorean identities for a moment, and you're saying, okay, so you have it in front of you. Remember, we don't have to have it memorized. What do we see when we see this first Pythagorean identity? Tan squared plus 1. Is that equivalent to something? It is equal to secant. Squared. Okay, so it is equal to secant squared of t. And what about 1 plus cotan squared?
Cosecant squared minus 1.
Okay, so that's equivalent to, oh good, cosecant squared minus 1. Okay, did that get me anywhere?
Wait, why is it minus one?
It's minus 1. Yeah, it is. Because the first one is...
Oh, no, it's not. It's what? It's just
Cosecant squared.
cosecant squared. Thanks, Lance.
Sorry.
You will.
I was looking in the right place
Looking for love in all the right places. So we have secant squared over cosecant squared, right? Okay, so did that get me really anywhere? No. It kind of did, believe it or not. The one thing it did is got rid of like 2 items in top, 2 items in bottom, and made it like one thing. So I could say, oh well, okay, so I'm so far I'm okay. Now, what was my next part of the old lady trick?
Sines.
Try to get back to sines and cosines, right? So what is secant equivalent to in terms of sines and cosines?
1 over cosine squared.
1 over cosine squared, and then cosecant is equivalent to
1 over sine.
1 over sine squared. Okay, so I'm cool so far. So now that I've taken my Pythagorean identities and recognized them, now I'm at a place where I have to kind of make the sine and cosine thing work for me. Now I have a fraction over a fraction, and it's being divided, so I do the reciprocal and multiply. Okay, so I'm going to take this guy and flip her up. So I've got this times this. So far, so good? Okay, if I wanted to rewrite it, because it's times numerator, numerator, denominator, denominator, what do I do?
Cross.
I got, we don't quite cross multiply, there's nothing to clean off. Yeah. Okay, there I am. Because I recognize the quotient identity, which means it's division of sine and cosine. Sine divided by cosine we know is tangent. Therefore, sine squared over cosine squared is tangent squared. So there is my answer. How do I know when I'm done?
You can't go to...
You can't go any further. So, a lot of people, that's the big dilemma here, is how do I know when I'm finished? How do I know that I'm at that place where I've stopped? This kind of starts to come naturally after a while, you know? What do we think? You want to do them by yourself? Absolutely. Okay, so let's do us a favor. Let's have everybody pick a different one and try it, and see if we can kind of talk about it and muster through them. So everybody kind of pick one if you could, and you know what, if you pick one and somebody else does, it's not a big deal. But try to pick one that you think somebody else might not. I might put that thing back down so you don't have that bar down in the middle. Kind of challenge yourself and see if you can find one that maybe I do. Layla, what'd you do? Which one? 16. You did number 16. So she did sine squared of t, cosine squared of t. That is a cotan. Squared of t. And then 1 minus sine squared. Great one to choose. Okay, tell me what you did. That's okay.
I switched the cotangent into cosine over sine.
Okay, so you said sine is good. I'm going to leave it as is for a moment. And I'm going to take the cotan and I'm going to make it cosine squared over sine squared over 1 minus sine squared. Is that what it looks like? Beautiful. Tell me what else.
The 1 minus sine squared on the bottom is cosine squared.
I am so excited because this is the place that people forget. And I think I did a good job this year trying to tell you, make sure you recognize it. Yay, excited. Okay, so cosine squared is what you told me is down there. Perfect. Can you do anything on top for me before I, yeah, well, maybe.
Can you cancel out the cosine on top?
You, well, okay, so what do we have here? This is over 1, really, right? Did you see it? Now you're telling me what to do, right? Okay. So what is she going to tell me to do next? She's going to say, oh, I recognize numerator, denominator for the sine squared, right, Layla? Yeah, good. So she recognized that, and then she got
And then
this.
it's 1. I did it right. Oh, yeah.
You picked that one, and she got 1. Woo woo! Yes,
Okay, can you do number 6?
I can. All right, 6 was tan squared t over 1 minus secant squared. Okay,
No,
beautiful.
wait. That's the one I did?
Maybe
No,
not.
that one.
Okay.
Number 10. I forgot
Okay.
to change the number.
It was close to 6. So we have secant squared t minus 1 over just plain tan.
If you're the same,
Is it really? Well, this one has squared, right, yeah. So close, but yeah. Okay, tell me now.
Okay, so I changed the top to tan squared.
And how do you know that's tan squared? The Pythagorean identity, remember we have the Pythagorean identities. We recognize it's Pythagorean identity because it has a square going on. And you said, okay, we got secant squared. Oh, I know if I subtract the 1, it is indeed just tan squared. Any questions on how that worked? Over tan. Perfect.
And then I did sine squared over cosine squared.
Okay, so you went the route of turning it into sine squared and cosine squared.
And then it was divided by cosine and sine.
Cosine.
I mean, no, sine and cosine, sorry.
That's okay.
And then I did the reciprocal.
Okay, so you said, oh, look, I see now fraction over fraction, so I know I should do reciprocal. Okay, good. And you know what? A lot of people would have just taken the tans and reduced them and then went. So, but your route, remember, the good news about these is whatever path you take, as long as you end up where you need to get, you're good to go. So she got to a place where she took her top and then took the reciprocal of her bottom. And then tell me what you did.
Cancel.
You started canceling things? Okay, so what did you cancel?
The cosine and the
So you said, oh, look, one of these can go away? Yeah? Okay, so what's left? This is gone, but one is left on the bottom? Okay, that's what you said?
and then the sines as well.
You did the same thing as, and it's really no different than x squared over x, right? So just sine,
Which was equal to 10.
which is equal to tan. Perfect. What's wrong? Yeah, and recognize here, okay, just Kalia,
Yeah.
here I say, oh, tan squared over tan, right?
And
So I could have just become tan right there, done. Now, are you done when you leave it in terms of the word tan, or are you done when you put sine over cosine? A lot of people like to fight the battle and say try to get to sines and cosines. If you're there at a place, tan is easier to use if you go into II and solving with it. So that would be perfect. All right, 15.
I have that too.
Did you?
Yes.
So, that's cool. A lot of people taking some of the things and now they're looking at them. So we have secant of t, tan of t over tan squared plus 1 of t. I sometimes lose a variable. Okay, now, what would we do?
I did secant times tan over secant squared.
Okay, so you said, I know that this is secant squared, so that's where your first step was? Okay, and so you just left this as is for a moment. Okay.
And then I did 1 over cosine times sine over cosine.
1 over cosine times sine over cosine all over.
Secant squared.
Okay, you left it as secant squared. Cool. Now what?
Then I have sine over cosine squared over secant squared.
Okay, so you said, okay, I have sine over cosine squared t over secant squared.
And then I did sine over cosine squared times secant squared over 1. Instead of, I brought secant over and did the reciprocal.
Okay, so you said this is really over 1.
Yeah.
And so you took the reciprocal and brought it up here? Is that what you're saying to me?
I didn't,
It's okay.
when I multiplied it should have been 1 over secant squared, but I don't think I did that. I did sine over cosine squared times secant squared over 1, and then I got sine times 1 over cosine squared over cosine squared. And then I ended up with sine over 1, and then I got sine as my answer.
Okay. And what'd you get?
I got sine as my answer.
You both got sine
Oh,
as
then
your
maybe
answer.
I did it right.
The thing is, the path that you take, it doesn't matter as long as you get to there. So you're saying you kind of left it at this, you brought it up to the reciprocal. What would you have done at this point?
First I turned secant squared into 1 over cosine squared.
Okay, so you recognize the reciprocal identity, that this is really 1 over.
Cosine squared, and then
Cosine.
the two fractions have the same denominator, so you can cancel it out.
So you learned my old lady trick that said, oh, I have fraction divided by fraction, same denominator, ignore denominator, I just left with
Sine.
sine. And you know what? If you don't recognize the old lady trick, you take this, flip it up, and know the cosine squares would cancel. You were on the right path. You just left it in word cosine, secant squared, and eventually you recognized that it was reducible because they became a sine and cosine thing. So far, so good. Yes, Jamie.
Can we do 18?
Sure. Do you guys like this?
Yes.
I know it's my favorite stuff to do. To me, it's like a party in math. Game board party every day. Okay, so cosine of t. Tell me secant of t minus cosine of t. Tell me what to do. This was 18.
Distribute.
Okay, so you distributed first, so you have cosine of t, secant of t, minus, and do you guys agree with me, cosine squared? Are you guys okay with that?
Yeah.
Anybody have questions about that? The way that you write squared, remember, it's kind of awkward looking, and let me go like an aside for a minute. Mistakes that people make. Cosine times cosine should be written as cosine little squared t. Can you foresee a mistake somebody may make?
Square the
t
t.
is squared. But if you think about it logically, the t would be the only thing that you would square if you plugged something in, rather than plugging something in and then squaring. Does that make sense what I'm trying to say? This also, just as another aside, cosine squared, just for future reference, cosine squared of t equals cosine of t squared. Those mean the same thing. 2 different ways to write it.
Cost.
Yeah,
So, are we going to just have a quiz on it or something?
we're gonna test on Friday.
Okay.
And we're gonna play with it for the rest of the week. We're gonna have a little puzzle game. We're gonna show some. I'm not gonna have you solve on Friday. I'm just truly gonna have you simplify. Tomorrow I'm going to incorporate verify into it, which means I give you the answer. You have to get to it. It's the same process thinking. It's just here's my answer. How do I get there? And so we're gonna play with those, and then I'm gonna give you a test on it on Friday.
Well,
I think it's a good test. It's a great, kind of like you guys believe that the series and sequence you did really well on it. I think this one you will as well. Okay, so keep going. Tell me what to do now.
What should call it? I turned the cosine into the fraction, so cosine over 1 and then secant, which was 1 over sine.
It's 1 over. It's 1 over cosine. Think about C goes with S, and S and C kind of pair up. Does that make sense? Okay, that's okay. That's why we're doing them this way, so we can figure that out.
Which equals 1 minus cosine.
Right. So this, well, becomes 1. That's where 1 is important. We don't always ignore 1. 1 becomes important here because it's really 1 minus cosine squared.
Which is sine squared.
Yay! And you know what? I'm so excited because you know what? Normally people don't see that. If you see that, yay, yes.
So 1 minus cosine squared theta is equivalent to just sine squared theta.
And how do you know that? Because of the Pythagorean identities.
And you always need to rewrite that, like on a test you would.
Yeah.
Can you use your 17?
Uh-huh. Cosine squared t minus 1 over cosine squared t tan squared t. All right, good. What do we got?
Well, I put cosine squared, the bottom one, over 1, and then change tangent to sine squared over t over cosine squared.
Okay, good. Excellent. What do we do on top?
And then the top I left it as cosine.
Did you?
Yeah.
You left it in?
No, I actually changed it to sine squared.
How?
Because that's what the
Pythagorean identity says, because we know sine squared plus cosine squared is 1. So if I, let's look at it for a minute. Sine squared plus cosine squared equals 1, right? And I want it to be cosine squared minus 1. So do you agree I subtract this guy over, and I also subtract that guy over there? So it's cosine squared minus 1 equals negative sine squared. You with me there? Did that make sense to everybody? Did anybody put that on their list of transformations? Probably not. That's a good one. Okay? So this, cosine squared minus 1, is negative sine squared of t. Are we good? Sweet. Now what?
And then I cross canceled the
Oh,
cosine.
okay. So you said, oh, look, cool.
Mhm.
Nice. So I'm left with negative sine squared over of t over sine squared of t.
And then we cancel out and then negative 1.
And so when I can cancel reduce by, reduce it, I got negative 1. Perfect. Do you guys like it? It's one of my favorite things to do. Okay, so anybody other numbers that you need me to do? Have I hit all of them, the ones you picked? You guys picked really great ones to work with. Let me show you what one of the questions on an AICE exam would look like.
I have a question.
Yeah, go ahead, honey.
Okay, so for number 19,
Yeah.
the ending was cosecant squared. So would you make that smaller into?
You can leave it cosecant squared. If it ends cosecant squared, just leave it cosecant squared, yeah. Because, what you would do with it is make it 1 over sine squared. What does that say? Half a dozen in one, 6 in another, however you want to do it.
6 and 1.
That too. You can tell I'm French, I say it backwards. Good excuse, Krajewski. Okay. I'm trying to find my mouse. Have you seen it yet? Yeah, I love technology. Oh, there it is. There it is. So, did you guys see it? No, you know why? It's on still. It has nothing to do with the technology. It's the user of the technology. I'm surprised. I'm sure you all are as well. Okay, here is some prime examples. Of course, in 2002, they're going to make life easy, right? Let's go to where it's not so easy. Let's go to more recent. Okay, look, this is an example of verify with an equal. Those are all verifies, which we haven't touched. Verifies. A verify.
That would be easy to write. It's just equal.
Get one, let's try one.
Do you want to try it?
Yeah.
Okay, cool. You guys are game. You guys like it as much as I do. Okay, this stuff to me, the verify, is really cool. I do have some old lady tricks that help every time. One of my old lady tricks is start with the ugliest side, what you would call the ugliest side. When I mean ugly, I mean more complex. 2 fractions rather than 1 fraction. It's easier to take 2 things and make it smaller than make 1 thing bigger, if that makes sense what I'm trying to say. It's easier to condense it by getting like terms and that sort of thing than try to make it bigger. So if I'm looking at this one, which one am I going to work with? Okay, I'm going to work with the left side. You're right. Okay, and I'm trying to make 2 fractions to become 1. So the rule of the game here is to take only one side and manipulate it. Do not touch the other side at all. Okay, so we chose together to do the left side. Would you agree? Uglier. Now that I've chosen the left side, I need to manipulate that as if it's a simplify. Okay, so it's really not much different than what we did. Now, I have 1 plus sine of x over cosine of x plus cosine of x over 1 plus sine of x. And ultimately, I want it to be really equal to,
You got 3.
that's what it has up there.
Oh.
They have 3. It's actually in reference to equivalence. It's equivalent to, but I say really equal to because I think that's cooler. So we have 1 plus sine over cosine plus cosine over 1 plus sine. Okay, again, we chose the left side because it's uglier. What are my other tricks of the trade? Remember, we want to try to get back into terms of sines and cosines. Is it already there? Yes. So that's cool. I don't have to worry about that for right now. Okay, I'm trying to take 2 fractions and make them 1. So in the real world, how do I take 2 fractions and combine them to be 1?
Same denominator.
I get a common denominator, right? So if I'm looking at this as fraction plus fraction, what would the common denominator be for this guy? Cosine x times 1 plus sine. Make sense what I just said? Okay? So the way I think about it in this case is I know that I have to get the same denominator. So the way my brain works, if it matters, you guys sometimes like it, sometimes think not, I do what I call cross multiply. I take this denominator and multiply it by this guy up here. I take this denominator and multiply it by this guy up here. And then I just put the 2 together on the bottom. It just it makes sense. This times this plus this times this over the guys together. You could do that with fractions. 1/2 plus 3/8. I do 8 times 1, 8, 2 times 3, 6, over 16. That's how I add without getting common denominators. And so then I have 14 out of 16, reduce it to lowest terms, life is good. Okay, it's just an old lady trick that I've been using forever. It seems to work every time. It does work every time, so why not use it for this? So this times this. Well, how do I handle 2 binomials multiplied together? I actually I'm going to FOIL. So I'm going to do it slowly. So today I'm not going to FOIL quite yet. So I'm going to write that as 1 plus sine. Okay. And then what's the next step? Remember, you start with the bottom right to the top left. Go to the bottom left to the top right. So plus what? Cosine squared, right? All over, and now leave the bottom as items multiplied. Don't actually do it. Don't clean the bottom until the very end. Okay? You're going to clean the top as much as you can and then resort to cleaning the bottom. So, what do I do for the top guy here?
Foil.
I FOIL this, okay? So, first plus sine, so how many are there? 2 of them, plus sine squared. Are we good so far? Okay. And plus cosine squared, all over. Remember, don't do anything to the bottom until you absolutely have to. So far, so good? Now what?
The sines and cosines.
Could you change the sine squared and the 2 sine to make 1 plus 2 the sine squared? Is that no? It's not.
Can you cancel the
Ignore that last
I know what you're saying.
cosine?
Tell me what to do.
Can you cancel the cosine?
No, because there's a plus going on in between there, so it had to be with cosine squared with everything. But you should go, Miss K, I see.
Sine squared.
Oh, you see 1
I see 1.
there. That's
I see 1 where?
right there. Sine squared plus.
I see 1 here.
Okay.
Why do I see 1 there?
Because sine squared plus cosine squared equals 1.
I get excited. Because that's a Pythagorean identity. You gotta recognize it when it comes. It might be
So it's 2.
in camouflage mode, but it's there. Okay? So I see 1. So what do I have? I've got 1 plus 2 sine x plus 1. How cool is that? Over cosine. Oh, I'm so bummed. We'll finish it tomorrow.